Hello and good evening, CSI 257 Section 847 students for the first 8-week term of the spring 2015 semester at Anne Arundel Community College. This evening's video tutorial is going to be on PacketTracer activity 6.2.3.6, where we're going to be configuring multi-area OSPF and answering a series of reflection questions that we have down here. So let's go ahead and jump right in. We've got our addressing table, which we should all be very familiar with by this point in the course. And in this activity, we're going to configure multi-area OSPF V2. The network is already connected and interfaces are configured with IPv4 addressing. We're going to go ahead and enable multi-area OSPF V2, verify connectivity, and then take a look at the operation. So the first step is configure OSPF V2 on router 1 with a process ID of 1 and a router ID of quad 1s. So let's go ahead and pull up the CLI for router 1. And we're in user exec mode. We'll transition to privilege exec mode and then into global config, where we're going to go ahead and issue the router config command, router OSPF, and it wants us to use a process ID of 1. So it wants the router ID to be the quad 1s, remembering that even though the form of the router ID is a 32-bit or a 4-byte IPv4 address, that's the format, this is not and doesn't have to be an IPv4 address. It certainly can be an IPv4 address if we have a loopback, for instance, that we've configured with quad 1s, but it doesn't have to be. This is just simply the format that the router ID takes. And if I were to back up and do a question mark, you can see OSPF router ID and IP address format. So again, we'll put the quad 1s in here and we'll hit enter. And the next thing it's going to ask us to do on router 1, it says advertise each directly connected network in OSPF V2 on router 1. And again, it's very straightforward. It's going to provide us with the command. So we're going to say network 10.1.1.0. So we're going to originate these routes now with the following commands and advertise these routes out. 255, and we're going to say this is in area 1. And then we're going to come back and say 10.1.2.0 with a wildcard mask of 0.0.0.255 for a /24 CIDR notation. And then the last one we're going to do is network 192.168.10.0, which is going to be a /30, right? So the wildcard mask would be 0.0.0.3. And this is our link into what is referred to as the backbone area, or area 0 in OSPF. All right, so there we go. So we've configured all of the origination statements with the network command under the OSPF config on router 1. It's now saying repeat the steps above for R2 and R3. However, we're going to be using different router IDs. And again, you're not going to want to have the same router ID inside your OSPF domain. Okay, so from user exec, we'll transition to privilege exec, and then into global config, where we're going to say router OSPF 1, and then the first command we'll run is we'll get the router ID set. So we say router ID 2.2.2.2, and it said configure each network, or I'm sorry, repeat the steps above for R2 and R3, and it looks like there are some network origination statements that we are going to go ahead and make here. So I'll add these in, and 0.0.0.255. Now, what area is this going to be in? Well, this is actually going to be in area 0, right? On router 2, all of router 2's interfaces are in area 0. So then we'll say network, and this is going to be 192.168.10.0. 0.0, and this is a slash 20 or slash 30, so it's going to be 0.0.0.3 area 0. And then we have another slash 30, which is going to be network 192.168.10.4. And that'll also be a slash 30. As you can see, the adjacencies are now coming up as well. And we would anticipate that there's going to be another adjacency here that we established with the router 3. Actually, we haven't configured router 3 yet, so if I were to do a do show IP OSPF neighbors, as you can see, we've got an adjacency with router 1, as well as what we would expect to be router 4 here, although we did not do any configuration there. So let's go ahead and hop onto router 3 here and round out our configuration tasks with router 3. And again, we go from user exec to privilege exec into global config, and we're going to say router OSPF 1. We're going to set our router ID to 3.3.3.3, and then we're going to use some network statements. And so this guy's 192.168.10.4, and again it's a slash 30, so it'll be a 0.0.0.3, and that interface on this router, on router 3, the interface that we're looking at is actually this interface right here, right, for that network, and he sits in area 0. So we're going to go ahead and put him into area 0, and this is where we should see an adjacency establish between router 3 and router 2. So if I were to say, and there we go, do show IP OSPF neighbor, as you can see, it shows our adjacency with router 2. Now the default priority for a point-to-point link, which this is, serial connection, is 0. So there will be no DR BDR election, which is why the adjacency is in a full state. However, there's no DR BDR identified because, again, this is point-to-point. Our dead timer, again, if I were to run this command, you'll see the dead timer will walk itself down to 30, at which point it will then go back up because it's received a hello, and there you go. And then it counts down from 40 seconds down to 30 seconds, which is when it'll receive its next hello, and then it'll continue on. And then the IP address, the 192.168.10.5, this is the IP address for the neighboring router out serial 001. So if I were to do a do show IP interface brief, you can see that we are, router 3 is 192.168.10.6, meaning that the other end of the link, which is router 2, is 10.5. And again, here's the interface out which I would see, or I'm seeing that neighbor. And there it is right there. All right, so we've got that set up. Let's do a do show run. Did I add in? I don't believe I added in all of the networks. I went right by it there. Yeah, so I've only put one network statement in. So let's add in network 192.168.2.0, and we're going to make this a slash 24. Now this is not in area 1. This, and actually there's 2 of them there, so let me slide this over here, make sure we don't miss anything. So these networks are in area 2. So we're going to originate 2 networks from area 2 into area 0. And you can see that we've got an adjacency with 6 and 7, and those are what's out here in the cloud, right? So those are the routers that will be out here in the cloud. However, we're not really concerned with the routers that are in the cloud for configuration purposes. So let's take a look at our results here. As you can see, this activity was very straightforward, right? So we've got all of our checks. We've got 80 out of 80. It's not reporting that on the other screen because I've actually had this has been up for a couple days waiting for me to get to it. So, and I've noticed that, and I don't know if it's the virtual machine, if it's low on memory or what the deal is, but it seems like when the PacketTracer activity has been left up for an extended period of time, the completion percentage will not autofill for you. If I were to reset this, we would be able to see that, but we already know we've got the 80 out of 80, and really the core of this activity is going to be in using the commands to examine each of these routers to make a determination on internal routes, intra-area routes as opposed to inter-area routes. We might even see some external routes. So which routers are internal routers? So remember, the definition of an internal router is a router that has all of its interfaces in the same area. And so then by definition, you can see router 3 has interfaces in area 0 as well as area 2. Router 1 has interfaces in area 0 as well as area 1. There's really only one router that we have visibility to here to be able to say that that is an internal router, and that would be router 2. And then which routers are backbone routers? And so any router with an interface in the backbone area is considered a backbone router. So we would say 1, 2, and 3 could be considered backbone routers. Question number 3, which routers are area border routers, or ABRs? And remember that the definition of an ABR is any router that has at least one interface in area 0 and one or more interfaces in other non-area 0 areas. So with that in mind, we can quickly determine here that router 1 and router 3, that these are ABRs, right? Because they have at least one interface that's in area 0, and then they have at least one or more interfaces that are in other non-area 0s, right? So we would say, for this one here, we're going to go with R2. For this one here, we're going to say R1, R2, and R3. And for this one here, we're going to say R2. Oops, sorry, we don't want R2. We're going to say R1 and R3. And so now it's asking us which routers are autonomous system routers. So before we do that, let's pull up the CLI for router 1. So if I were to type in, want to make sure we leverage some of these commands here. So if I were to say show IP protocols, do show IP protocols. So if I said do show IP protocols, we're going to end up with a pretty significant amount of information here, but very good information. It's going to show us the OSPF process ID number. It's going to say number of areas in this router is 2, and they are both normal areas, right? So I'm routing for which networks? 10110/24, 10112/24, as well as the 192.168.10/30, right? So what information do I know about the other routing sources that are out there on the network with me? Well, I know about the router with the router ID of 1111, 2222, 333, 444, 555, and 999. What if I were to type in do show IP route? And again, remember, we're on router 1 here. So now you can see I have a number of intra-area routes, right? Routes that are native to the area in which this interface resides. And this 192.168.10.0, right? If we take a look at that, if we scroll back up here, you can see that that was one of the areas that we were in, right? 192.168.10.0. So I also have 2 inter-area routes, right? And so these are routes that are from outside my area, right? Or the areas that I am in. So router 1 is in area 0 and area 1. If I were to drop this down a skosh, you can see that the 2 prefixes that we're learning about here, 192.168.1.0 and .2.0 are coming out of area 2. And so we're going to actually answer a question here that'll be asked in a few steps. So what happens out here, right, is which routers generate type 1 LSAs? And the answer to that is every router generates a type 1 LSA for itself to represent itself and to represent the networks that it knows about, right? So every router generates a type 1 LSA. So router 3, upon learning about the type 1 LSAs that are in the areas to which he is connected, and again, this is router 3 we're talking about, what's going to happen is, and that is not what we wanted there. Let's go jump back over here. And PacketTracer, where did that go? I apologize. I've hit that a couple times before, and it throws the screen into chaos. Oh, actually, desktop. There we go. So from router 3's perspective, he gets a type 1, or he learns about the type 1 LSAs that are in his area. And then what he does is he will inject a type 3 LSA into area 0, right? So the networks that router 3 knows about that are in area 2, he will learn about those from type 1 LSAs, right? Maybe even his own LSA. And that information will get injected, right, into area 0 as type 3 LSAs. And so to see that, let's pull up router 2. So on router 2, if I were to type, go from user exec into privilege exec and type show IP route, you can see that router 2 is also learning about those two routes. And router 2 also sees both of those routes as OSPF inter-area routes. Now, there's a key distinction to be made here between intra-area and inter-area. Now, remember, the intra-area routes, those will simply be an O, the letter O by themselves, without the IA. And we saw that on router 3. Or I'm sorry, let's do show IP route. I think we're on router 1 there. So on router 3, so this is considered an intra-area route, right? These are considered inter-area routes. And so a very key concept to remember, not only for the CCNA, but as you move on with your Cisco studies, if you decide to move on to the CCNP, is that intra-area routes will always be preferred over inter-area routes, and that is irrespective of the cost. So if I had two routes to the same destination, and one was intra-area and the other was inter-area, the intra-area route, even if I had set the IP OSPF cost to 65535, which is the maximum cost in OSPF, even if I had set the maximum cost on an intra-area route to 65535, it would still be more preferable and selected for insertion into the RIB, the routing information base, or the routing table that we're looking at, over the inter-area route, right? So make sure to remember that. All right, so we see a number of type 3 LSAs that have been learned by router 3 as well. He's learning about the networks that are over here behind router 1 in area 1. So if I were to type do show IP OSPF database, what do I see? Let's roll back up here. Kind of rolled off the screen there. So it tells me my router ID and the process ID that I'm using on this router. As you can see here, router link states in area 0. And so router link states, these are the type 1 LSAs that I am learning about. So I am getting a type 1 LSA from router 4, which we don't see here on the screen, and I'm assuming is sitting out here in the quote-unquote cloud. I'm getting a type 1 LSA from router 1 because remember, router 1 has an interface in area 0, as do I, router 3. So I'm going to see a type 1 LSA for him. Type 1 LSA also for router 2 because we're all in area 0 together. Now, the next one is an interesting one. And sorry about that, kind of scrolling off here. All right, so net link states in area 0. Now, these are type 2 LSAs. These are network LSAs. And if you remember, the only time you see a type 2 LSA is if there's a DR BDR in that area. And so if we were to type in, I'll come back to that, do show IP OSPF neighbors, do I see a DR and a BDR? Well, I do, and again, this is out off of over here in the cloud to the right, area 2, right? So this is in area 2. Now, I've got a serial link, so there is not a DR BDR election between router 2 and 3. However, if I take a look at router 2, show IP OSPF neighbor, router 4 is the DR, right? So you can clearly see that router 4 is the DR. If I do a show IP OSPF, let's see, I don't want to do interface, let's just show IP protocols. If I do a show IP protocols, right, you can see that it gives me my information that I'm using OSPF process ID 1. Number of areas, I have a single area. I'm in area 0. I'm routing for these networks here, and it is show IP OSPF interface. There we go. All right, so let's take a look here. So the gig 00 link is up, and its adjacency is with router 4, who is out in that cloud that we don't have visibility into. But you can see here that the state, my state is the BDR, right? So there is a DR and a BDR. The DR is router 4, probably because it has the higher router ID, which is 4.4.4.4. I am the BDR on this segment, and so therefore, when router 3 is looking at his database information, he's going to see that network advertisement for the link 10212, which is coming off of router 4, and that's the router that's advertising that type 2 LSA. So now let's take a look at our type 3 LSA. So here are the type 3 LSAs, and let's remember that when we say summary network link state, that does not mean summarization in the context of route summarization. So I'm not taking 4 or 6 or 10 IPv4 routes and then trying to come up with a summary route. That is not what this summary means in this context. What it means here is that this is a summary of the information from another area. And so let's take a look at the first two that we have here. So these are both coming from router 1, who we know to be in area 1 right here. You can see the link IDs, right? The advertising router. So these are the two networks that we're talking about, the 10120 and the 10110. And then the same thing. And again, remember, we're on router 3 here. So router 3 is also learning, or were we on router 3 here? Let me clear the screen real quick here. This writing's getting in the way. Yeah, we're on router 3, okay. And so you can see he's also receiving summary network advertisements for 192.168.2.0 and 1.0. And so, and again, that's for the interface that's in area 0. If we look here, the router link states, again, we're on router 3 for area 2, what is he learning? So let's see, he's learning router link states, so type 1 LSAs. So here's the link ID and the advertise. So this is typically the router ID that you'll see in both of those fields. But then he's also learning these type 2 LSAs, the network LSAs, because as you can see here, we're going to have a DR-BDR election. It looks like we've got broadcast network types over here, not serial links. And then the summary links for area 2. So he's learning about the 10210, which is the transit network between router 2 and his cloud in area 0. We're learning about the transit network links, the 2 serial links, and we're learning about the 2 networks that are in area 1. So these will all be type 3 LSAs because all of these networks, these links, right, these link state advertisements are coming from outside of area 2. The advertising router is us. It's router 3 because again, router 3 has an interface in area 0. All right, so I think that's answered some of these other questions here. So which routers are autonomous system routers? And the way that you can tell this is if I were to say do show IP OSPF interface, it's actually going to tell me, or actually was it do show IP protocols? No, I believe it was show interface. Let me double check on this. May not have gone down far enough. Where are we at here? Adjacent neighbor count. So it should tell us in this output, and I might be scrolling right by it, it should say that this router is an area border router. Let's see, maybe it's the wrong interface. So we see the backup designated router, BDR, but that's not what I'm looking for, and I'm not sure if I'm looking right by it or not on the serial interface here. Yeah, I don't see what I'm looking for. I may have to pull up, because what we should see is it should tell us that it's an autonomous, or I'm sorry, not autonomous, that it's an area border router. And I'm not sure, maybe I've got the wrong command. Give me 2 seconds here. All right, so let me pull up, let's see here. We'll pull up, this is a real Cisco 1841 router and show IP protocols. Let me make sure that, yeah, so show IP OSPF interface. And I am drawing a complete blank right now. Show IP OSPF, and it should be not neighbor. How about interface FA00? Now, is that going to give us the same information? It is show IP OSPF. There we go. I think that, yeah, that's what I was looking for. I apologize. All right, show IP OSPF, which I didn't see over there. So if I were to say do show IP OSPF, which we don't have listed over here, but it's a really good command, you can see that it's going to tell me right here, it is an area border router, right? So router 3, without a doubt, is an area border router. So what does router 2 say? So we'll say show IP OSPF, and let's see what router 2 says he is. And so it doesn't say anything for router 2, right? But he is in area 0, so he is definitely, all of his interfaces are in area 0. So this is truly an internal router as well as a backbone router. So then router 1 should show us that it is an ABR as well. So we'll go from user exec to privilege exec, show IP OSPF, and there you go. It is an area border router. And in some cases, you'll see that it'll say, because it can be an area border router and an autonomous system boundary router, which is what we should see here on this router. And let's see if it tells us that. And here it is right here. So it is an area border router and autonomous system boundary router. So a router can have more than one role in your network, in an OSPF network. And so for here, we're just looking at 2 ABRs. So let's see. So which routers are generating type 3s? It's going to be router 1 and router 3. The type 2s, or we saw they're coming from router 4, 6, and 7. And I believe 1 and 3 are also generating type 2s within their areas. Again, every router generates a type 1 for itself. So which routers are generating type 4 and type 5 LSAs? Well, I didn't see any type 4 or type 5 LSAs. So if I do a show IP route, if I was seeing a type 5 LSA, which is what the type 4 LSA is associated with, I would expect to see an OE1 or an OE2. And if I roll back up here just a skosh, you can see that the external E1 OSPF external type 1 metric or type 2. And so these are the routes that you would expect to see that are coming from outside of OSPF period, right? Or they've been redistributed into OSPF, right? So that's what the external, and if I'm not mistaken, I may be able to pull this right back up here and give you an example of that. So we don't see any type 4s or type 5s, but if I type show IP route, do I have the OE2s? Yeah, there we go. Okay, fantastic. So we get a chance to take a look here. So these OE2s, right, OSPF, and they're referred to as type 5 autonomous system external, right? And the metric type, it's either E1 or E2. And while this is way outside the scope of CCNA, this is actually CCIE territory, I want to go ahead and explain it. Very simple explanation, right? So that you have an idea and an understanding that there is a difference between the metric type that we see there, the E1 and the E2. It's the same thing with N1 and N2. And so what does that mean to be an E1 or an E2? Well, if it's an E1, remember, these are external routes, and these are coming from outside of the OSPF domain altogether, or they've been redistributed, which by definition means that they're coming from outside of OSPF. So when we have a type 5, right, so if I were to type show IP OSPF database, take a look here. So this is what that looks like. It'll tell me it's a type 5 AS external link state. So these are type 5 LSAs. I'm receiving the type 5 LSAs for these 3 networks here, right, 10222. And again, these are /32s, these first 2 here, because they're loopback addresses. And this is just a transit network here. And so there's no coincidence that they are the exact same routes that we see up here with this E2 next to them, right? Because that is a type 5 AS external. So what is the difference between the 1 and the 2, the E1 and E2? And so very simply put, since these are coming from outside of OSPF, these are external to the OSPF domain, a type 1 would say, I'm interested not only in the external cost to get to me, but I also want to take into consideration any internal cost. And by internal, we mean internal to the OSPF domain. And so let me I'll throw a drawing up here real quick. So what that means is, so let's say that router 2 has an additional interface here, right? That is not in area 0. And it's a serial link, and it comes out here to the internet. And there's a router here on this other side. If this router is sending in, and let's say it's sending in BGP, right? A BGP route. And this is clearly not OSPF, right? So what we would expect to see is a type 5 LSA that would be, and the default metric type is E2. And so where E1, he cares about what's the cost here. And I want to know about the cost here. And I want to know about these costs over here. And I want to know about all of the internal costs. This is what the E1 metric type is interested in. So in addition to that, he is concerned about the cost out here as well. So when we say E1, he wants to know about the internal costs and the external costs for a route. He wants to know end to end, what does this look like, so that I can make the most informed decision. E2 is just the opposite, where E2, the only cost he is worried about is the external cost. So E2 does not care about any of these costs that might be associated with getting into and out of the network. He doesn't care about the internal cost. And again, E2 is the default. So you will always see E2 unless you have set it to be an E1. And so again, a little outside the scope of the CCNA, but definitely something I wanted to explain. We had some students on Saturday that said, well, what's the difference between E1 and E2? Why would a route have E1 as opposed to E2? And so this is why. And in fact, if you Google, there is a brilliant article, blog post on this by Brian McGahan at INE. So if you Google OSPF Type 5, I think it's Type 5 E1, E2, INE, and that's I as in India, N as in Nancy, E as in Edward, metric types, you'll find the blog post. And it is a phenomenal blog about the differences between E1 and E2. And again, it's outside CCNA, but it doesn't hurt to have an understanding as to what the difference is between those two metrics. All right, so let me go ahead and transition back now. Let's clear the screen, and we'll come back now. So the type 5s, right? The type 5s are going to show up as OE2. And again, I don't have any type 4s here. And I don't think we have any type 4s at all over here. So let's take a quick look. So show IP OSPF database. We would see an ABR summary, and I don't see it there, and I don't see show IP route. I don't believe there are. No, so those are inter-area, but these are type 3. So the OIA is a type 3. And again, I don't think we have... Yeah, all OIAs. Okay, so again, the type 4, no router. It doesn't appear that any of these routers is generating type 4s. So how many inter-area routers, or inter-area routes, does each router have? Well, each router will have the routes for areas and inter-area, right? Remember, inter-area is the type 3. So here is, this is router 3. So he has 2 inter-area routes because he does not have an interface in area 1. So area 1 routes will show up as OIA inter-area routes. Router 2 should have none, if I'm not mistaken. Oh, no, I'm sorry. That's right. He's picking them up. So he's all in area 0. So he's going to have the 2 from area 1 as well as the 2 from area 2, as you can see here with the OIA. Again, these are inter-area routes. And then router 1 should be just like router 3, show IP route with his 2. Right. So there they are. Okay. Why would there usually be an autonomous system boundary router in this type of network? And so the reason was what I had just drawn up before. As of right now, everything is sort of hermetically sealed in these 3 areas, but at some point we may have, and that's where router 2 would no longer be simply an internal router if he had, an interface that went out here to the internet. And at this point, right, if he's receiving external routes, he would be considered an autonomous system boundary router, or ASBR. And it would really probably be this guy here, if this is, if the thinking here with the drawing is that these guys are maybe going out to the internet, that those would be your autonomous system boundary routers, but they're clearly solely maintained within this area, and so therefore we don't have, as of right now, any autonomous system boundary routers. All right. Well, that wraps up PacketTracer tutorial 6.2.3.6 on how to configure multi-area OSPF. And so we talked about a lot in this video, right? We talked about what the difference between intra and inter-area routes are. We took a look at the different types of LSAs, 1, 2, 3, and 5. We learned how to identify those LSAs with the show IP OSPF database output. We also took a look at a little review where we saw how router 1 and 2 and 3 and 2 did not have a BDR election, because again, those are point-to-point links and those are point-to-point network types, and so there is no BDR election, so our priority there was 0. And then we also saw for review that router 1 with its routers behind it and router 3 with its routers behind it, as well as router 2 and its routers behind it in those clouds there, that they did form adjacencies and elect DR and BDRs, because those network types, which were non-point-to-point, are broadcast network types. And so we also talked about the difference between the E1 and the E2. Again, chances are you are never going to see that in the CCNA curriculum in terms of having to know what the difference is and when it would be generated and how do I generate it. But again, a great concept to be aware of, the difference between the E1 and the E2. And again, the E1, he takes into consideration the cost of every link, internal and external, when making his decision. An E2 does not. An E2 is simply interested in the external metric, right? Okay, so again, I hope this has cleared up any confusion that you might have had and clarified multi-area OSPF, as well as the LSA types, how to find information on those LSA types, and how to determine what your multi-area OSPF configuration looks like. All right, thanks for watching, and I will see you all Saturday morning.